let's start with the who. Who are we? First, by means of introduction. So my name is Alex Lodock. I do HPC at Chevron. But more than that, oh yeah, well, let you introduce first as well. More than that, I'm here as Alex that does HPC. So don't worry about me being a representative of Chevron. Yes, I am, but I took my Chevron shirt off and I try to make it clear that I'm not here as a spokesperson for that company. I'm here as a participant of the HPC community, because what we're trying to do here is to, basically we're pitching a community activity to you. We're here to ask for your participation in something that we're trying to do, that we have been trying to do. And we can talk a bit more about who we are in this context, but that is what we're here for. So it's less a presentation of something that we have done. It is more a pitch, an invitation to come join us in this effort that we are pursuing and contribute to that. With that, maybe I should give you a chance to say who you are.
Thanks, Alex. I'm Alex Morris. I work for Microsoft. I also do HPC. I know a number of you in the room. As Alex said, we've been working on stuff and I think that we want to really get the community input. So it's mostly over to Alex.
How's this supposed to work? Yes, well, okay, so the key thing is we wanted to do a poll here because we need your feedback on, or we wanted to gather your feedback on that. And for that, I needed leave it, it's okay. It's not helpful. Okay, so well, we just have to wing it and see whether we can get this poll out to you in a different way. Well, we can do it live. So what we have been talking about and what we have been working about, again, we being primarily, well, not just Alex and I, there's a group of us, but yes, it's people from Microsoft and from Chevron. The other way around, Chevron and Microsoft. But again, that doesn't matter. But what we have been working on is working towards a framework that allows us to run HPC workloads in a cloud environment in a more cloud-native fashion. I should preface this. I don't want, at this point, I don't want to talk about should we be doing cloud? Is that a good thing? Is that a stupid thing? Is it more expensive? Is it less expensive? I'm happy to talk about that as much as I can. And I have in the past and in this venue and others, but today is not about that. And what we're proposing, this activity, is not about that either. It is based on the idea that that somebody wants to use cloud and wants to do it in a way that it gives them the benefits that cloud has to offer, which is primarily scalability and elasticity. Maybe some others, but those are the two main things that we're after. And the observation that we in Chevron, with our partners at Microsoft, have done in doing that, in trying to run HPC workloads in the cloud, that it is doable, but in order to, again, get the benefits, we need other tools than what we are used to using in an on-premise environment. Yes, there are POSIX file systems, there are parallel file systems in any cloud provider, but that is not really the cloud native way of doing it. Can you do it and does that serve a purpose? Yes, it does. But if you really want to get the benefit of running in the cloud, you need to use the tools that cloud provide you. Same with resource management. We are running Slurm in our Azure environment, and that works really well for those workloads. But what I'm postulating is that is not the right way of running HPC workloads in a cloud native way. And
it's the same deck that came to Keith.
But there's a second. Go to slide 3. Perfect.
Oh, okay.
Thanks. we'll get to that. So that we're postulating that we need a different tool set. And for those of you that have tried running HPC workloads in the cloud with more native cloud onboard tools, you yes. Okay, fair question. So, okay, since this is the Energy HPC conference, yes, it's fair to ask. I'm coming at this from the workloads that we in oil and gas know, and that is primarily imaging or seismic or whatever moniker you want to use. And that is the reason, or that is a good distinction, because those workloads actually lend themselves very well to be run in a cloudy way, if you know what I mean by that, right? Those are workloads that do not require a low latency interconnect between your workers or between the nodes involved, right? What you need is a whole bunch of workers, and then, yeah, you need fast storage and then a mechanism to move data around or do data aggregation, or whatever you want to call that. And those are things that cloud has to offer. But today, if you want to use that, you have to write your own tool set for that. And we have seen that at this conference and at others. There are always at least one or two presentations that show, oh, I ran FWI in cloud provider X, and it was great. And here is the tooling that I built myself for that. Okay, so that's what we were addressing. Now that we have the right slide and the QR code up, now I can ask everyone, and I saw most of you did that already, take a screenshot of this, go to the URL, it takes you to a Microsoft Teams form. Oh, I shouldn't have said that. Doesn't matter that it is a Microsoft Teams, that was just the tool that I used. It takes you to a poll, very quick. I would ask you to respond to that poll. Again, don't think too much about it, just put your answers in, and we're going to look at the results here and then shape the discussion based on that. At least something works. The only thing is now that since we're using that laptop, we can't show the results. But yeah, I apologize for the technical challenges here. I didn't know until 10 minutes ago that I could not use my laptop for this. But so the first question that I asked of you was, why do you use cloud and what for? And see a bit more than a quarter of the responses say not at all, which is fair. I hope that you still find something useful in this activity and in the product of that we're here after. There's a lot of about an equal amount of responses that say they use cloud for bursting. There are some responses that state that they intend to use cloud or are using cloud as a direct replacement for an on-premise environment. So the main purpose of this question was just to get a temperature check of where is everybody and what is the relative position towards cloud. The other thing is, if you try to use cloud in the same way or for the same purpose that you use cloud as you use an on-premise environment, for example, running MPI workloads that require low latency, that absolutely changes your picture and the tool set that you need, because then you do need MPI. We're not here to come up with a different MPI. That problem has been, well, I say that problem has been solved, and MPI is a good tool for that. Is it the best tool? No, but that's a different conversation. So that helps. So, but I do see, especially knowing the audience here, people running seismic imaging workloads, I know that there are people out here that can make use of cloud in a different way. Okay, coming to the concerns that you have about using cloud. The leading concern there is indeed cost, and that is fair, that is understandable. Like I said at the beginning, our goal here is not to debate whether or not cloud is expensive or cheap, or is it cheaper or more expensive. What we can talk about is that if you either choose to use cloud or have to use cloud, the second answer on the first question, what can you do to make that actually useful and as painless as possible, and make sure that you do get all the benefit out of running in the cloud, which then reduces the price. I see an equal distribution of lower answer count, but equal block of people or responses that say they are concerned about performance, about orchestration, about vendor lock-in, and the effort that it takes to migrate to cloud. And those really are the aspects that we're trying to address here by coming up.
I would say that while I'm a representative of Microsoft here, the goal is to get participation from other cloud vendors and make sure that this isn't a framework for Microsoft, but for everybody, and be more. I mean, the purpose of the conference is for industry, so it's really for industry to be able to use the tools that the cloud provides.
I'll jump into the fourth answer in interest of time. Question was, what tools do you use if you are using cloud today? And there's of course a percentage that says, no, we're not using cloud at all today. There is a strong mentioning of people using traditional or typical HPC tools, POSIX files, things like MPI resource schedulers. And again, that is totally fine, that works. I know full well that it works because we're doing it. But there are also some answers that say they use homegrown frameworks or they use cloud-provided services. And that is the part of the cloud usage that we're trying to address. And maybe we should talk still a bit about the what is it that we're actually trying to do here. I want to get us as a community beyond the yet another one-off of running a workload in the cloud. Everybody here in the room, I'm sure, can or has done this of setting up a workload to use cloud-native services, third-party tools, or write your own framework to orchestrate your workload in the cloud without using Slurm. Or maybe adopting Slurm to be more flexible and spin up nodes and up and down. I'm pretty sure everybody here, again, can do that or has done that. But nobody has reused any tools that somebody else in this room already used. Everybody has to redo that every single time. And that is not the way this is equivalent, in my opinion, to the world of HPC before MPI became a standard and everybody wrote their own POSIX, their own socket tools to do communication between nodes. Or everybody writing their own parallel file system to get better throughput out of a file system. We need to get beyond that. There are a lot of efforts already underway, right? This conference is proof of that. The SCG is proof of that workshop last year. There is a lot of stuff out there, but it's still one-offs. Everybody does it themselves. And we as a community, if we then so choose to use cloud, either willingly or forced, we will have to solve this problem. Otherwise, we'll be stuck in this situation that everybody has to write their own tools. So I propose that we as a community should start working towards defining what that looks like. And so what we're specifically asking for is your participation in a workshop or in a format like a workshop where we get together, leave our badges and our egos at the door. This is not about one company versus the other, or I like this cloud provider better than the other. Same for the cloud providers. This is not a venue where people pitch their services. We have to come to this as a community, as HPC practitioners from different sites that all have a shared interest in that, but that want to work towards defining what that could look like and make progress towards towards developing this. And maybe just a quick view of what that workshop looks like. This is not really an agenda, but those are the topics that I see us discussing there. So first, rehash, what is it again that we're talking about? What's the scope? What's the purpose? What should that look like? We do need to spend some time discuss what's already out there. And I hope that some of you have in your minds like, well, hang on a minute, Alex, that doesn't thing X already do this? So I should pick something else but X. Thanks, Elon. Doesn't this thing already exist? Doesn't that do exactly what you want? I hope that some of you are already thinking that, because that is what we need to hear to then figure out, does that really serve this purpose? Or is that lacking things, and what can we add, what can we adopt? Maybe even, do we really need this? Because if I'm the only one who thinks we need this, then I probably need to hear this, and I might shut up, and you guys can go about using cloud the way that you think it should be used. But I'm pretty sure that, that we do need it. And then the meat of the discussion will be around, okay, what does it do? What is the functionality that this framework should provide? What are the right, I call it primitives, right? What are the basic building blocks that this system would provide? What are the performance requirements, right? We all know that we need lots of I/O bandwidth because we all read and write large amounts of data. We need to quantify that a bit so that the cloud providers can understand what we're asking for. We also need to talk a bit about what parts of this are things that that cloud providers have to deliver, like the actual underlying service. What are the things that we as a community want to put into this framework, and what are things that users still have to do them, or developers still have to do themselves? Right, this is that will be critical to make sure that everybody can participate. Well, and then another question is that I also hope that is in some of y'all's minds right now. Okay, is this the same thing as OSDU? Fair question. The off-the-cuff answer is no. I think you phrased it really good, right? We need some kind of governance ultimately, but we don't want the government and the taxes that OSDU represents that we all have to pay by playing along. So this is not to create another standards body. This is very much a community-driven thing where we need to define what it is that we want and start building it without getting hung up in the governance of running a 200-party organization. With that, we are talking about hosting a workshop. We don't have a specific date yet. Mostly because it's a bit of chicken and egg, right? We need to know who all wants to be involved. How big is that community that we're getting together? So I'm inviting you right now to scan this QR code. That's the second poll. Just quickly say whether or not you're interested in all and whether what we said makes sense to you. If you want to be directly, want us to be able to directly reach out to you, leave your email in there as well. Otherwise, both of these polls are anonymous. But what I promise is what we will be doing is we will put together a workshop in the April-May timeframe, about half a day here in Houston, at least because that's the community that we're working with. The assumption is that most of you are in this area or have some gravity to this place, and we will find ways to announce this and invite you to that. Again, the purpose of today's session was to give you a little bit of a bigger pitch on what it is that we're after. So if you do get that invite for this workshop, you have at least, hopefully, a little bit better of an idea of what it is that we're after. And I think that concludes our presentation here.
Alex, I have a question. I mean, when you say cloud, you mean cloud providers. But cloud, in my opinion, is just a technology. Yep. And you can have that on premise. You don't need to go to a provider. So would be the ideal thing to think of an installation somewhere on premise, and how would you operate that?
Yes. So that is fair. So what I'm proposing, or what I'm talking about, is an abstraction layer. Maybe call it that. It's an abstraction layer that targets specifically resources that are cloud-like in the sense that it is not a fixed sized installation. But if you have a fixed size installation, then what you need is a resource scheduler, something that allocates workload to that fixed size resource. You need a queuing system. If you have a fixed size system under your control, it's a lot easier to put in things like a parallel file system. Putting a parallel file system in the cloud environment is doable. I know for a fact that it is. We have been using it for the last 2 years. It works well. It works just as well or not as well as it does on premise. But the technology that a large-scale hyperscaler, whatever, insert your word there, a technology that they deploy because it fits their operating model is different. But Lustre is not a cloud-native technology. And yes, you can make it work, but it's not scalable. It's just the wrong technology for that environment. There are other technologies out there in the cloud, object storage, S3, GCS, whatever, insert your product name, that work really well in a cloud environment, but they are incredibly painful to use with HPC codes in an HPC program. Can you make it? Absolutely. We've done it. We have written, some of you hopefully have heard of Coffee, the Chevron optimization framework for imaging and inversion. Please tell Sam that I mentioned the name. We have written that, and it allows us to use object storage from an HPC application. But we had to write it ourselves. We had to figure out how to use object storage. We had to figure out how to shard, and here comes my favorite example. We had to figure out how to shard across multiple storage accounts. We had to figure out what regional storage accounts are. None of that is, well, very little of that is publicly documented in a way that you can actually discover it. But you have to figure that out in order to run HPC workloads against that environment. So that is the difference for me between on-prem and cloud. Cloud gives you technologies that are not transparent. You don't really know how they work. You can't explore that easily. And that is why we need this abstraction layer. If we do it right, that abstraction layer works perfectly against a parallel file system like Lustre. Again, our Coffee does that. We can swap that out. I don't see a reason why it wouldn't be. But the main goal is to have an abstraction layer that lets us use cloudy resources, whether they are on-prem or somewhere else. I did not. Is that why you sabotaged my slides?
Hi, thank you for the talk and thank you for your time. I was wondering if you have heard of or familiar with the Open Chamois project?
Yes, I've heard of it. I don't want to say that I'm familiar with it.
Okay. So, words are hard. So it is a community of primarily sysadmins from primarily from national labs and academic circles, but also industry, who are working on creating a new paradigm for HPC orchestration that uses modern technologies like HTTPS microservices. It's written in Go. It's all run as containers. And the idea is that it's agnostic to whatever it's running on. So you can use this framework on-prem and the cloud both. If it sounds like that might be a good project to look into, because it sounds like that the community aspect that you're looking for and the people who are thinking in that direction are there, and they're talking now. So
that sounds wonderful. And like I said, I was hoping that in your collective minds there already are things like that. And I'm pretty sure there are maybe 2 more. I hope so. And best case is this workshop, we go through that, we figure out, yeah, this thing does 95% of what we want. We just need to add 5% or maybe 15% to make it a bit better. And then we have to work on adoption. That is absolutely actually a desired outcome. I'm not saying we need to build, this is not an XKCD where I say, what, we have 14 standards, that's unacceptable, right? And we need to build the 15th one. That is not what I'm after. So thank you. Thank you for that. And yes, this is what we will need, early on to make sure that we know what's already out there.
thank you.
Yeah, and in your little survey there, of course, you mentioned cost was one of the first drivers and concerns, and I mean, we know who controls the cost, but I think there needs to be, yeah, there's a technology aspect, but then the economic aspect too. Like, I mean, anyone who's deployed cloud at scale creates a new department called financial operations that has to really go after, you know, the FinOps side of it and optimizing your cost, and that's some too, just a misunderstanding or a misuse of the services where you got to go through and really find those optimizations. So if there are projects out there around that, because that's also something that people have to build internally, and then you usually build it after the fact, because then you're, you know, you can estimate cost and all this, and then when you really start using it, you realize you had some blind spots and things like that, and you got to go
Yeah,
really
I
after
think,
that.
I mean, there's a lot of different services that you find out that you're using, and I think from my perspective, transparency is the key thing, and then you can go and address what you think is good, you know, cost that you're prepared to pay for and cost that you're not, I don't want to pay this amount for this device, but the overall cost for the environment and making it transparent. That's the idea. Yep.
Sure. No, you're right. Cost is a big thing, and I'm not trying to pretend that, you know, this is not an issue. It absolutely is. I think it's a related, and you pointed out a connection point, but it is still a much bigger separate conversation. Although I would say, well, if you do it in a naive way, if you get your cloud allocation, you spin up your, I don't know how many nodes, you leave them on and wait for users to come, then it gets really expensive, right? And I think something like this can help not having to figure out how to avoid that cost. You not having to figure out how to turn nodes off in Slurm and make them come back on when you turn them on again. Right? Those are all solved problems. It's just that there are 15 different ways of solving them. And if all of us were forced to try it out or want to try it out, we would all pick different paths, and that is unnecessary.